Next, if we look at part C, well, this is going to come off of the information for what we've done here. We can see that we have a max up here and at here, and then a min at 0. So if I want a max and I have to justify, I can say f has a max. Now notice it says what values of x, so I don't want to know what the y coordinates are yet. I might later, but right now I just want the values of x. So f has a max at x equals plus or minus a half because f is continuous. Now in my notes I think I also have that f prime of x at those values equals 0 because differentiability will imply continuity, so really you could put either one of those statements. And f prime changes from positive to negative. Secondly, we have a min at x equals 0, and the reason that happens is because, again, f is continuous. We saw up at the top that f had no problems when it came to 0. We could plug that in, so we're going to be continuous, and f prime changes from, this time at 0, we're changing from negative to positive. So point breakdown on this is we get 1 point for the max with justification, and we get 1 point for the min with justification. So 1 point here. Next, part D. What is the horizontal asymptote of f? And we have to justify using limit notation. So this takes us all the way back to chapter 2. We want horizontal asymptotes, so that means we've got to look at the limit as x approaches infinity of f of x. Well, if I look at f of x, on the right side, I'm looking at x to the 1/4 over an e to the x to the 4th. And in this case, we're going to see what grows faster, a 4th root or an exponential. Since the exponential grows much, much faster, we will have this over a gigantic number, which will eventually get us close to 0. Because of the even nature, our limit as I approach negative infinity of f of x is going to get close to the same thing. So that means my horizontal asymptote, the only one I've got, is y equals 0. Final part D is to put it all together. Well, we've already got a rough sketch based on what we had up here. So we know behavior near the origin means we need to plug 0 into the function. So I come all the way up to the function, and I can plug in 0 and see that a 0 comes out, which will give me this point. Then I can plug in -1 and 1 all the way up at the top. That would give me 1 to the 4th root, so that's going to be a 1, and then e to the -1. So I know my top value at both of these values will be 1, 1 over e. And I could do that over here as well, a -1 and a 1 over e. And then if we look at the behavior near the origin, well, let's go look at our derivative. If I try to plug in things that are close to 0, this is going to get closer and closer to negative infinity or positive infinity, because when I try to divide by 0, things blow up on me. That means we're probably, instead of having a nice pretty corner, we're going to have a cusp. So we can translate that cusp here and go up and up. And then we want the max and min locations. Well, we've got that. Here's my 0, 0. My locations at 1 and -1. And now we need behavior for large x. Well, that behavior comes from the horizontal asymptote. So we'll roll back down and get close to 0. And that's it. Oh, point breakdown, I forgot. For that part, we get 1 point for the horizontal asymptote, and we get 2 points, one for having a cusp here at 0, 0, and another point for having the correct increasing and then decreasing behavior on both sides.